Hi everybody, my name is Mike Roeder, and I'm the lead architect and developer of this product. So I have to show you the disclaimer in terms of, IBM statement and so on. You've probably seen it. In terms of the product itself, Data Set Commander is consisting of currently 3 components: a IEBCOPY comparable batch utility, an ALA refresh monitor, and a ISPF Productivity interactive component. It's been GA. This release has been GA since July of last year, 2013. Okay, a few words about history of this product. It was acquired by IBM in 2005 from IBM Corporation. It used to be called Spiffy. Since then, at IBM, it's gone through major enhancements and improvements. And in the last 2 releases, it became not only an ISPF productivity tool, but we've increased the scope of the product into a batch utility, which we'll see later, and a LLA monitor, which will be a basis probably for additional functionality over there. In terms of the mission of the product, the mission today is to provide enhanced productivity and automated functionality to ZOS-based data set operations. And that's why we also changed the name from ISPF Productivity Tool to Data Set Commander. What we're trying to do is to basically exploit as much as possible and complement existing ZOS and ISPF services with minimum customization. Okay, so the product seamlessly integrates itself into ISPF, and in the case of the batch utility, you'll see into the batch environment. In terms of what happened in the last release, what we've added, the most significant components with this LLA monitor component, and also for the first time, you may have heard by now, in ZOS version 2.1, PDSE supports what is called member generations, which is a similar concept to generation data sets. When you save a member, you may create, another generation of that member, and like a previous version. And DSE version 8 exploits this functionality and is able to display those member generations and allow you to manipulate them. We'll see that in the demo. There is a lot to cover here, so instead of going through the presentation, what I'm going to do is, after a short overview of the architecture and main approach functionality, I'm going to get into the demo. In terms of architecture, basically on the interactive component, DSE is a front end to ISPF. When you start your session, actually what you're starting is DSE, and DSE basically attaches ISPF as a subtask, and thus has full control over the ISPF environment. In addition, it tries to be, as much as possible, what is called object-oriented, meaning that similarly to, if you like, a Windows environment, when you select a file of a certain type, DSE will try to invoke the corresponding, if you like, file handler. So If you go after, for example, a vsend file, okay, BSE will invoke your selected for your environment vsend handler, which may be something like File Manager or File 8 of CS3, and so on. Same thing is true with IEBCOPY. We have, you'll see the batch utility component, which actually runs on top of an IEBCOPY engine, and it's on one hand fully compatible to IEBCOPY, meaning that all the IEBCOPY control statements and so on, forms, okay, are supported, plus additional significant functionality on top of it. It is ZOS release independent, meaning that in a sysplex, for example, where you may run different ZOS levels, okay, on different LPARs, you can share one DSC, release across all these LPARs, regardless of the ZOS releases. Okay. In terms of the general philosophy of this product, since obviously, if you look at the ISPF environment, the ISPF, if you like, ecosystem, there's a lot of products there, there's a lot of interfaces and so on. So what we're trying to do is to simplify as much as possible your ISPF environment, work. And to do it in a way where you don't have to learn the whole product, okay, but you can actually pick up whatever functionality is applicable to you as you go along, while maintaining, your previous, if you like, ISPF work habits, and little by little increase your productivity by making use of more and more DSE functionality. We're trying to make it as intuitive as possible, and I'll show you the examples later. You'll see what I mean by that, meaning that you have to remember less. And if you forget something, there is an online assist in every case which helps you, remind you about certain functions that you may need to use. Here is a whole bunch of functions that this product can do for you, essentially, and you can see it here at the bottom. Okay, when you look at ISPF in general, okay, as you probably know, options 1, 2, namely browse, edit, view, 3.3, which is the copy function, 3.4, which is DSList, and option 6, which is DSO, are typically the routine functions that every application programmer is using. All right? In each of those functions, okay, DSE adds productivity, functionality to make it even easier to use. And on top of it, when you really become used to a DSE, you never have to actually even use those options from the main screen. They are available from anywhere at any time, and we'll see how. All right? So with that in mind, let me jump right into a demo and start showing you what I'm talking about. This is an ISPF environment with, as you can see, DSE version 8.1 installed. And basically, you know what, I'm going to start from ready. Let's say I'm in TSO ready. As you know, when you start ISPF, you basically type ISPF, and you get into, into the primary menu, okay? Now, in terms of customization, you don't need to customize your ISPF environment in any way. All you need to do is to take the current ISPF panel or C list, okay, and add the D cards of the DSC target libraries, okay, for the typical ISPF DD cards, such as ISP L-Live for load lives, ISP P-Live for panel libraries, and so on. Right? And DSE is there, okay, to be used. Now, in terms of the general, if you like, functionality of DSE, which is available for anywhere at any time, the general approach is that every list that you create of important objects, such as lists of data sets, or lists of members, or lists of volumes, okay, or lists of commands, TSO commands, okay, become a launch platform, okay, to basically execute anything you want against those objects. So, for example, let's say I want to display all the data set names, okay, that meet that pattern. Notice there's no dots in this pattern. Okay? I press enter, and from here I get all these data sets that are meeting this pattern. You're actually looking at what is called an object list. Object list is a more generalized, if you like, concept compared to DS list. In the simplest case, it's actually a list of data sets, okay? But an object list can contain other types of objects. For example, it can contain patterns, okay? I could have said here, okay, something like that. And when I select it, I'm going to get, you know, all the data sets that are matching this pattern, right? So this is an object list, and we'll see later what we can do with it, okay? When I select, oops, this is not there. Okay, so let's select something that does. Okay, here's a library. I'm now into a member selection list. Again, from here, okay, I can not only browse, but actually do delete, rename, and so on from here, and we'll see that. Another list that I can show you is a list of volumes, okay? I'm now looking at all the volumes that start with user, okay? So anyway, this is a volume list, okay? And from this volume list, I can drill into, all right, the data sets on that volume. If you notice, I basically got, again, an O list of all the data sets, okay, that are on this volume. Okay? User 01. Okay? Another thing to notice is that I'm still in one split. All this functionality is available without opening another split. Okay? Let's go to option 6. Okay, or I'm going to do it differently. All right? This is the TSO shell of DSE. Okay, now, if you noticed, okay, what happened here at the same time was that the command line was initialized with the most recent command, okay, that was entered. Okay? And you can simply just press enter or, you know, override it. Also, what you see here is, unlike ISPF, where you can save up to, you know, 10 most recently used commands, you can have here, you know, hundreds of commands, or let's say in this case it's customized to have 100. Okay? So that's another list, and from here, okay, I can, for example, option 6, line number 6 is this submit. I can execute it from here. I can say 6, okay, and that job was submitted. Okay? So, all right, back to where we were. Okay, we're here. We were here. Now, where were all these commands came from? Okay, they are what is called command shortcuts. Okay, and this is the first thing that I'd like people to know, to be aware of. There is a command, DSE question mark, that basically displays all the command shortcuts, and they are available from anywhere at any time. Okay? Now, we talked about being intuitive. Let's look at some of the commands. Although there is like 68, they are actually pretty easy to be used. Okay? Well, you see here BREDVI, or Browse, Edit, View. Okay? I want to browse something. I can simply say browse, say, I don't know, sys1.netline. Okay? And I'm in it. Okay? Same thing I could do, edit. Okay? If you go further down, you'll see a whole bunch of command shortcuts which start with O or OL. And they are the object list related command shortcuts. Some of them I showed you. Okay? I showed you, for example, OL stands for OList, object list. Okay? OList pattern. Okay? Now, there are other variations of OList. Okay? In DSList, as you know, you basically can specify just a DS name pattern. Okay, and even that is pretty limited. Let's see. Let me bring here just so that we know what we're talking about. This is basically ISPF. Okay, now if you recall, I did something like, okay, and as you can see, okay, ISPF DSList does not support patterns like this. Okay, all right. OList does. Okay, as we've seen. The other thing that OList can do for you, okay, is go after certain classes of data sets. For example, I want to look for all the vSAM clusters, okay, matching a certain pattern. Okay. OLVS or OLVSAM, intuitively named, okay. Let's say SP stores. Okay. Now, this is an OList of basically vSAM clusters matching that pattern. Okay. Now, one of the things that you can see, okay, you see this column here, volume. Okay. OList has two modes, if you like, of displaying this column. Okay. In a typical environment with DFSMS, most data sets are cataloged, especially vSAM. So the volume column is not that important. Much more important is to know what class is this object. Okay, and to do that, okay, if you double click on the column, point and shoot on the column, or you simply say show val, a command, you can see now the display with the data set names and their class. Now, if you notice, all right, we have here theoretically two types of classes. Okay, vSAM, which is just a vSAM cluster, and a class called Zone, which is also a vSAM cluster, but happens to be also a SMP global zone. All right? But anyway, okay, when I select, all right, any of those objects, all right, in this environment, the vSAM handler is IBM File Manager. So now I'm actually looking into this vSAM cluster through File Manager, and I can browse and look at what's in there. Okay, and an example of object-oriented. Okay. Some other interesting, if you like, OList-related, lists. I want to look at my DB concatenation for a certain library, for a certain set of libraries in my JCL. Okay, so for example, as most of you probably know, ISPF DB name ISPP plib is the panel library concatenation of mine. Here they are. Okay. Okay, and again, this is an O list. I want to look at GDGs, OLG, or OLGDG. Okay. Let's say this is a display of generation data sets. As you can see, okay, you not only get the generation data set names, okay, the actual names, but also the generation number, the corresponding generation number. All right? Okay. Another very useful O list is the O list of the most recently used data sets, or OH, for O history. Okay? Data set history. All right? Now, until now, okay, all I've shown you was what is called temporary O lists. In other words, object lists that are built on the fly. Okay? In addition to those, I can now store, okay, object lists and make them permanent. Okay? So, and I can start, okay, from anywhere. I can, for example, open a new, give it a name, okay? New, let's say, new list. Let's see what happens, okay? I want to create an O list called new list, okay? Okay? It's not existing yet, so what I get is some kind of a initialization based on the most recently used things that I used, plus, you know, a bunch of comments, as you can see here. And I can now edit this thing, okay? I can populate it. For example, if I do a slash, okay, I can populate it from different sources, okay? Let's say I want to populate from some system related lists, say PalmLight. Okay. So now I added to this list, okay, a PalmLight. I can go to full edit and start editing this. Okay. So let's say I'm going to leave that. I'm going to delete these, delete the comments. Right. And boom. Okay. And now I just stored it. Okay. Where can I find all these permanent, what is called permanent O lists? Well, here is a shortcut, okay, to display them. Okay. And as you can see, I have all kinds of permanent O lists. One of them is new list, the one that just created. Okay. And okay. Okay. Now, the default, if I just say O list, okay, I get the most recently used permanent O list. Okay. Now let's look at what kind of functions or functionality is available for an O list. The command to show you that is the online assist, A. All right. And as you can see, all right, there is a whole bunch of what is called main commands and line commands that you can use to act upon the objects that are displayed in the object list. You want to know more about, you know, what you can do with each command, you bring the cursor underneath, as it says here, you press enter, and you get a more detailed explanation, syntax, comments, examples, and so on. okay, about how to use the command. Okay? Now, the same thing is true for MSL, for member selection list. Okay? Well, this one is has just one member, but basically we're in a member selection list. Again, regardless of where we came to this member selection list, okay, we can browse, we can edit, okay. Oh, okay, this is a load module. Okay, so let's come here. Okay. Yeah, here I can do edit, I can do delete, I can do rename, and so on, okay? So unlike in ISPF, where you have, for example, when you do option 1, you can do only browse. We can do option 2, you can do only edit. 3.1, you know, delete, rename. Obviously, 3.4 is a different member selection list. When you display a member selection list in DSC, you can do any of those functions against the members in that list. And the same thing is true with OList. Regardless of where you came to the OList, the minute you display it, you know, all the functionality of OList is available there. So now, let me go to a OList that I prepared for this demo. Just to remind myself, I called it demo. And let's look at some typical functionality that may be interesting for you. All right, let's start with number 2. Okay, I'm looking at okay, a bunch of libraries that are called, you know, that have tiny in them. We'll see why. I want to show you a clone command. I want to clone the model. Okay. I want to call it dir. Okay. I just created, okay, a clone of my model. Okay, and as you can see, the cursor is pointing to the clone that you just created. I'm going to go into it, and I'm going to try create a new module, a new member. Doesn't matter what I put here. Oops. Okay, obviously what happened here, as the name says, okay, it's really a library with a tiny directory. And as you can see, when I did the save, okay, there was no room in the directory for this extra member. So unlike ISPF, where you're going to get, you typically get an aband, and basically, you know, you lose your session. DSC intersects this condition and allows you to extend the directory, a directory block, okay, which is what it prompts you here. So I'm going to say yes. As you can see, the member was saved. And one of the commands that you have in you know, a member selection called info shows me what I have there, and okay, and actually when I started there was one block, and now there are 2 blocks of directory entry. So that's, you know, an example of, whoops, where was it? Let's go back here. Another example is this model. I'm going to do the same thing. Okay. This is a tiny PDS, meaning it doesn't have a lot of space. Okay. Let's say I'll take this. We'll save. Okay, I was able to save it. Another save. Whoops, ran out of space. Okay, again, normally you get this abend in ISPF. Okay, in our case, we intercept it. Okay, and we allow you to compress it if you let us compress. Okay, now it was compressed and the member was saved. Okay. So that's that. Let's look at other interesting functions. Okay, I'm looking here at all the data sets that, as you can see, have SPIF in them, 7.1, A, and so on. Okay, there's quite a few of them. Okay, what happened here? You notice the message migrated or hidden? Okay, well, this is because what is called show migrated off functionality is on. Okay? What this does is it filters out all the migrated data sets out of this list. So if I go to the flip side of this list, you see, I can see all the data sets. Now, show mig is a on-off. So if I enter it again, okay, and refresh, right, I'll see all the data sets. Okay? But anyway, I'm here, and I'd like to find all the members, okay, that have, let's see, let's see. Okay. I'm looking for all the members that have I in the first character, some wildcard in the second, third character I, and S in the fourth, and the rest of we don't care. Okay? Okay? So it's fast. Okay. Now, what happened here? At the same time, we not only found all the data sets, okay, that all the libraries, okay, that have that member name pattern, but we also excluded the other side of the list, okay, all those that don't match the pattern. Okay, now I can go anywhere here, for example, to this library. If I select it, okay, I get a member list that includes all these names. Okay, I go here, maybe that's better, all right, and so this is member find. Okay, let's go back here and do another thing. Okay, I want to look for a character string on all these data sets. ABC. The command for that is find text. Okay, there's quite a few data sets here, but it's pretty fast. And okay, and the same thing happened here. All right, all the data sets that don't have that character string are out on the hidden side, on the flip side, and here I have all those that, you know, include that character string. If I select one of them, okay, as you noticed, the command line is already initialized with find ABC. I press enter, here's ABC. Right? Now, when it comes to libraries, all right, for example, this library here, okay, the find text, okay, stops at the first occurrence of the first member that has that character string, all right? Again, we do that because you may have a lot of data sets, and it may take, quite some time. But you can now drill down. Let's say in this case, I'm in this library, which is a pretty big library, okay? And I want to now search for all the members, okay, that include ABC. The command for that is global, or global find ABC. Okay. And now I'm searching on all the members. This is a pretty big library. All right. Okay. Again, same idea. I can exclude, to the flip side, all those that don't match. Okay, and I'm here. Okay, now I can drill down further. Okay. I'm now looking at a subset that includes ABC. Let's say I want to now look for, from here, I want to see all those that on top of ABC maybe have XYZ. Let's see if there is any. Oh, yeah, there are. Okay. So, again, this is a quick find. Let's look at the global change. All right? Okay, we'll do it by, again, also showing on the way other things that you can do from an O list. Well, this is an object type. That means I want to look at DD sysproc of my JCL. Okay, so I'm going to select it, and here's the concatenation. Now, this is an O list. Right? So I can use the clone command. For example, I'd like to clone this. Okay. Fine, let's call it this way. All right. Here we are. We just cloned it. Okay. And I'm going to go here, and I want to change the character string user into, say, visitor, just for the fun of it. Okay. Command for that is global change. Okay. Now, what happens in global change as opposed to, global find is what we do is we enter edit for every member with a list of edit type commands, such as change. You can add to this other commands, okay? So that's why you get this prompt, okay? So, all right, but in this case, I'm going to leave it as is. And there you get this prompt. You say enter, okay? Okay, now again, same idea. All these were not changed because they didn't have a user in them. Let's go here, find visit. Okay, okay. This was a user before. Okay, so we just did a global change. All right. Okay, what do we have here? Yeah, okay. This is actually a clone of sys1 MacLib. They're a pretty big library, as you can see, 18,000 members. Okay. Now, what I'm going to do is, let's delete all the members that start with A. Okay. See, I get a prompt. Okay, there's no A's anymore. Now, what I want to do is, I'd like to recover them. I'm in a PDF. This is a PDF. Okay, the command to do that is called map. Let's see what happens. Okay. Now, what this command does is, it basically reads the entire library okay, and creates a map by PTR of all the member data, sections, okay? So anyway, we're here, okay, and let me sort by what is called synonyms, okay? What's happening is this, okay? In this display, okay, all the deleted sections, okay, don't have names because they don't have directory entries, okay? So what we've done here is, okay, we gave them what is called synonym names, which are basically starting with 9Z, as you can see here, and followed by the PTR, okay, this is the PTR, the address, if you like, of that, deleted member, if you like, section, okay? All right? Now, this is a deleted member, okay? I can browse it, okay? And, okay, as you can see, this member was called ACI, I guess. So I can come back and say, restore. Oh, okay, I should have put the name. Okay. What I did was a restore, okay, without telling what to restore it to what name, okay? So by default, what he does is he gives it a member name, which is equal to the synonym name, which is what happened here. Okay, so now, actually, we have a member by this name. Okay, let's look here what we have. Okay, this is a member that used to be called NSUXTT. Okay. All right. Oops. Anyway. Oh, no. Let's go back here. Refresh. Here are the deleted members that we just restored. So I can look at them and rename them to anything I want. Like okay, so now we're back with the deleted member restored. Okay, another functionality. Okay, this is an example of a concatenation. Okay, as you can see, the concatenation is displayed with 4 levels here. Okay, the lower level is this, second level, third level, fourth level. Okay, now this is typical in a ISPF PDF type development environment. Okay, so this would be equivalent if I just did a BR to display option 1, if you like, to this concatenation. You see? All right. Now, for a concatenation, you can switch, all right, from this concatenation to other types, okay, of that same concatenation. So typically, like in this case, okay, I have also a set of corresponding libraries that are like for the load modules. All I did was, if I wanted to switch to that concatenation, was the type command, all right? As you can see. And I'm back here, all right? As opposed to going to option 1 and changing here, okay, to load. All right? And there are all kinds of other things that we can do here. For example, okay, I have here Jcl Libraries, and I have a job. I want to show you something here. I'm going to submit this job. It's basically a compile. A compile from a source of that concatenation into a load module. Now, before I'm going to open a SDSF window. Okay. So now I have two splits. Okay. A interesting command shortcut that you have is called iname, okay, which will do the following. I want to call this screen, okay, split screen, I want to call it demo. You notice what happened? Okay. We got what is called the swap bar. That's an ISPF function. But what we did in one shot in this command shortcut is we both activated the ISPF swap bar plus gave a name to that split. So now, okay, and as you can see, SDSF has the name SDSF. Okay, I'm going to go to this was the job that I just ran. All right. And here is our concatenation. Now I am in SDSF, okay? I'm looking at this JCL, and I want to actually look at this library from the JCL. Well, I can point and shoot at that name and put a command in the command line, browse, okay, and I'm in this library. This is called point and shoot, all right? Better than that, I can, in the keys, okay, I can define a PF, typically, like in this case, PF4, okay, is not exactly used, okay, so I can bring the cursor underneath the object and just press PF4, and I'm into browse for that object. That's point and shoot. Okay, and all right. So this is this. Okay. Let's go to some other examples that could be useful. We saw. Let's go to edit. Okay, I'm going to go to my history. Okay, list, object list, history, and okay, I can be here. I want to now demonstrate the batch utility. Okay, we were supposed to mention the batch utility, and here's some examples. First of all, let's look at IEBCOPY. Okay, this is typically an IEBCOPY syntax. As you are familiar with, this is the copy statement, ODD, INDD, select member, okay? Now, as far as continuation goes, okay, if you can continue a control statement, you must put a character in column 72 and resume the next continuation from column 16. All right? Now, in the batch utility, as an example, let's take this. Oh, okay. Okay, here's an example, pretty complex, but maybe shows you the stuff that you can do in a batch utility, just examples. Okay, number one, in addition to, here is a copy, okay, copy statement. In addition to be able to do copy in DD, out DD, okay, you can, like in IEBCOPY, you can do an out DD. O is out DD, okay, and you can do also in DSN, out DSN. Namely, instead of specifying the data set names in the D cards, okay, you can specify them in the control statements to be able to dynamically allocate them. Another thing that you can do is virtually all the various partitioned related, okay, member manipulations, such as delete, rename, alias, okay, so on. Plus, what you can do is use member name patterns, okay, both against PDSs and PDSEs. Right? And finally, okay, this is not, yeah, here's an example of a continuation. The continuation syntax, okay, is similar to JCL, namely, you don't have to put anything in column 72, okay, and you can continue anywhere, okay, from column 2 on in the next statement, okay. Now let's see what happens when I run this. By the way, the name of the batch utility is IQIBUtil. Okay, I'm going to submit this job. Okay, just finished. Here it is. Let's see what it does. Okay, all right. The output of this utility is a combination of IEBCOPY related, okay, output. As you can see here, IB, you see all the IB messages, plus the batch utility, okay, additional information on top of it, going in a organized way, okay, into the same output. Okay? So, as you can see here, okay, here's the batch utility. Here are, without getting into too much detail, basically your original, if you recall, control statement. And what we do here is we give each control statement a sequence number so that we can refer to it from the report further down of the execution. Another thing that's happening here, unlike IEBCOPY, is that the entire input stream is parsed ahead of execution. Unlike IEBCOPY, as you know, if you have any sometimes syntax errors or any problems, okay, IEBCOPY will continue, okay, trying to execute a control statement. Even though if you have an error, you know, it's much better to basically not even start the whole thing. Okay. So anyway, the batch utility, first of all, parses the entire system and makes sure that it's all, you know, valid and legit. In this case, we had an NDD, so we dynamically allocated. It tells you that. And then we had to delete a bunch of data sets, a bunch of members, which we did. Okay? But there was nothing there matching the pattern. Okay, so he tells you that, hey, you know, there was no new asterisk. Okay, that's why that filter was irrelevant. We now proceeded to the copy function. Copy function was passed to the IEBCOPY, if you like, engine. IEBCOPY did its thing, as you can see here. All right. And then we proceeded to do renames. All right. And as you can see here, member name, memo1 was renamed to this, and so on. Right. Okay. Finally, okay, we were done. So we dynamically unallocated the file that we dynamically allocated at the beginning of this process. This is the batch utility. And there are other things that it can do. Again, we're running short on time. What I want to show you as the last thing is the LLA monitor. Right? Now, in this environment, what we have, okay, is we're running in a sysplex, and we have basically 4 nodes in the sysplex, each one of them running the LLA monitor. Okay. The command shortcut to display the monitor control center application is dfcmon. Okay. And as you can see, I can start it from anywhere. All right. This is the main menu. One of the options here is to display the LLA monitors. And as you can see, okay, I have 4 nodes. Okay, my node, I'm on sysg. Okay, so this is the local node, and then we have a sys A, SP23, and SP13. Also, they have different ZOS levels. Okay, sysg is 113, sys23 is 2.1, sys A I think is 111, and 13 is again I think 2.1. All right. Let's look at the monitor from SDSF. This is basically the monitor output. Now, what I've done is, all right, again, since, as you know, LLA is a privileged function, okay, and it's controlled from PARM line, the system PARM line, through a bunch of CSV LLA like this here, okay, LLA XXX members. In this environment, we actually even don't have LLA, but what we can do is to simulate LLA so that I don't have to change any system libraries, okay? And what we do is, okay, there is a special DD card, okay, that simulates PARM-like in this environment, but the SVC to refresh LLA, okay, basically works in any case, even if you don't have LLA, and it basically ignores, all right, directory entries of non-LLA managed libraries. All right? So what I've done here is, okay, we use my, if you like, source and load and object libraries of simply the development, okay, to be monitored by these monitors, okay? So every time I change something, okay, I can see that it was reflected, okay, in that monitor activity. Okay? So let's just look at an example. I'm going to start. I'm opening a concatenation under SCLM, if you like. All right. And, okay, I'm going to make a little change. Okay, let's do it here. This is a macro, okay? And let's do renum. Save it. Okay. We just stored this macro in that library in dev.lsm. Now, if I look here, notice the monitor, okay, was actually notified, okay, dynamically, that this member was just saved in this library, okay, and it refreshed the LLA for that member. Not only that, it also sent a note about that, a message, to all its other, okay, monitor nodes, okay, on the sysplex, okay? So if I go, okay, let me go here, and I'll activate. Yeah, we are here on SP23. Remember, this was one of the nodes? Okay, I'm going to take a look at this monitor. Okay, again, you notice this is a different, node than the flex. He also got that node, and he just refreshed that same member over there. Now, I'm going to go back to where I am, okay? And okay, and display the monitored LLA libraries. Okay, if I sort by last refresh, as you can see, this was the library where I just stored the member, okay? And it was just refreshed. Okay. Okay. Now let's do, where was it? Going to delete the name. Okay. Actually, I'm actually doing, a build under SCLM from MSL, if you notice. Okay, I'm going to do okay. What I've just done is, okay, I actually submitted through this a compile link edit of, here we go. Okay. We just, by doing this, okay, this is like a build of a component, okay, for SCLM, but basically what this did was compile all the members that include that macro that we just updated, okay? So it's a combination of not only compiling the members and creating list members for those, and object code, object member, but also load modules. Now let's go to the monitor. Okay, where's the monitor? I think it's here. Okay. And, oh, no, let's look first, monitor log. Okay. These are, after we updated this member and we build that component, okay, these are, okay, the object code members that were put into this library. And since this library is, monitored for LLA, as if it's an LLA monitored library, the monitor got notified about it and refreshed supposedly the directory entries for it. Here are listings of the same layer, object, load modules, okay? And if I go to here, and I again refresh that screen, just press enter, okay, as you can see, okay, all these libraries, okay, have been just refreshed. Here is their timestamp, okay? And if I go here, that's the other node and the L part, all right? Again, they were refreshed over there. So this is basically, okay, the automated LLA refresh facility. That's how it works. Now, in terms of what you can do from the control center application, okay, you can, unlike, you know, the manual way of the GOS gives you, which allows you simply to, you know, refresh a whole library group, a whole LLA library group, okay, from a console command, you can get down to the level of specific members, okay, and refresh only those members, or refresh any selected node. You can also manually, okay, do that from here, okay. This is, by the way, a display of all the LLA groups that are defined in this environment. In other words, all the CSV LLA, you know, groups that are normally in Palm, let's say. So, for example, in this case, okay, I drill further down and I get all the libraries pertaining to this group. Right? I can go, let's say I'm here. Okay, I'm going to drill down to the library. I get the list of members. Okay, now I can come here and say refresh, and I get this screen. Okay, and I can now override these names, leave them as is. Okay, and tell the monitor to refresh either locally or do it on all the other nodes at the same time. Okay? So I'm going to do that. I'm going to put A for all. Okay? And let's see what happens. So first of all, on the monitor, as you can see, he just tells me, this was actually the command that was entered. Okay? All of these commands are also available from the console, you know, to the modify command. Okay? Okay. So we can do it on a member level even. Okay. Other things that we can do here from this place. We can control the monitor from here. Okay. We can change the status. We can pause the monitor. We can shut it down, and pause, resume. All right. The message facility is the output that you've seen before, okay, from SDSF. Right? That, if it grows too long, you can spin it off, okay, from here. Namely, close it and reopen it dynamically. Right? There are all kinds of timer-related options that you can have. All right? The time that you want to wait before you refresh an entry. It's called a time delay. You can decide that at a certain time of the day, like in this case, okay, 1 o'clock, okay, you want to force a refresh of all the LLA monitored libraries, to put them in sync, if you like. Or you could do it at midnight, and so on. All right? And there are all kinds of diagnostics that, we can run traces and snaps. Right? Finally, the last thing that I want to show is member generations, before I forget. Okay. This is another environment that has the latest ZOS 2.1, with member generation support. And I created in that environment for myself an OList called memgen, just to remind me. Okay? And here's a bunch of libraries. Okay? Now, first of all, let's go to 3.2, which is the allocate. Oh, I can do it. Let's look at some of the new things that, I'm going to call it PDS2. Okay, if you look at the allocate new data set, panel, these are the two new fields that are available for PDSEs. Okay, one is called data set version. Okay, and it must be PDSE version 2 in order for it to support member generation. The other parameter is the maximum number of member generations, okay, for this data set. In this case, I put 10. Okay, so if you press enter, you're going to get that library allocated. All right? So that's on the allocate. All right? Now, going back here, all right? Okay. Yeah. What I created, okay, is a clone with member generations, okay, out of this library, SIQI. This is the target library that contains CList. Right? Now, if you noticed, all right, when you display a library that has member generations, the member list has a new column called gener, or generation, okay? And it shows the relative generation of that member. In this case, okay, we only have generation 0 because I didn't edit anything. But I'm going to go and say edit this member. Oh, I'm sorry, I put R, I meant E. All right, just for example, I'm going to delete it for the fun of it. Okay. You notice? Okay, what happened was a member was saved. Okay. The previous version is now generation -1. Okay. And I can display it. Right, this is the original member. Okay. And this is now the current generation. Remember, I deleted a member. Okay. If I keep doing it, okay, let's say that I'm gonna another update. Okay, now, okay, I created a new generation -1, which was my previous generation of this member. Okay, and here is, the oldest, the very first generation that I created. Okay. Now, what can we do with that? Okay. First of all, we can, for example, recover. Let's say these are, different versions of, that member, and I'd like to recover an older generation. Say this generation -2. Okay. Okay, I'm going to show you the assist. Okay. One of the commands here is generation recover. Okay. Or, okay, there's also a G here. A line command for generation recovery. Okay. So I'm coming here and I'm going to say G. Okay. I get this prompt asking me, do you really want to recover that generation? I'm going to press enter and watch what happens. Okay. Generation 0 now, okay, is what used to be generation minus 2. This is really my original version of that number. Okay? Now, the previous generation 0, which was this, okay, was pushed down, okay, and became generation minus 1, and so on. Now, this happens until you reach the maximum number of generations, which is 10 for this library. As soon as you reach 10, okay, like in GDG's data sets, okay, the generations above 10, relative general above 10, will be dropped. Okay? Now, another thing that you can do, I'm going to go here to, for example, this library. You can do a copy from one library to another along with the generations. Okay? So, okay, I could, for example, say, let's say copy ABC 001. I'm going to get this prompt. Do I really want to copy just generation 0 or generation 0 with all its member generations? I'm going to say yes. Okay. So now he's asking me where to go to. Okay. I'm going to notice, okay, this is, again, another example of how DSC intercepts certain ISPF functions, such as, in this case, this copy panel, and adds, okay, functionality to that same panel. One of the things that it adds here is this @H, okay, which you can point and shoot at. And what this will do is, it will, instead of you typing the name of the target, it will display the history list, okay, and allow you to select, okay, a target library from that history list. So I'm going to go to source 2, press enter, okay, and okay, as you can see, all these were copied. Now let's go to that library. Again, I want to go to that library. It must be in the history list, right? As you can see, source 2 is now at the top of the history list. Now, if you notice, okay, and that's a little peculiar with member generations until you really realize what's happening, all right? On this library, I have already 10 generations of the same member, okay? Because I already did the same copy before, all right? But what's happening is, okay, I'm gonna go to the previous, okay. What's happening is that these copies these things were copied in the right order so that these, okay, 5 levels, if you like, 0 to -4, in the target will be equal to these. You notice? 13, 13, 10, 7, 5. Same thing here. So, all right. And whatever was there in terms of ABC 001 was pushed down the generation stack, if you like. Okay? So -5 was basically what used to be generation 0 before we did the copy. Huh? Now, you can also delete generations. Okay, so for example, I can come here and I can delete this. Okay, it prompts me with a content. Okay, now this is gone. Okay. You can delete, okay, let's see, if I do it from here, it will prompt me, do I want to delete with all the member generations? Okay, I'm going to say yes. There's no ABC01. Okay, by the way, we have a nice red book, okay, and another much bigger, presentation called a workshop presentation, which I can make available to whoever is interested.